Welcome to another short repair video. In this video I have a KVM switch, model number CS72U, and what this is designed to do is work with multiple PCs using just one keyboard, mouse and monitor. What comes out of your PC and into this is your VGA, and this is the same, and either one of them can be selected with the switches here on the front. These switches are working because the light flashes back and forth as you press them. And what I'm told is happening is when you switch, it doesn't control the PCs. I'm not too sure about the video at the moment, but we'll get there. First of all, we'll do a few checks on this, some voltage checks. What I'm going to have to do is set up a USB, use its own proper cable on it, because it's powered by the actual one of the clients that are connected to it. Okay, I have one of the cables. It's just connected to a USB hub at the moment to give out 5 volts to simulate another PC. As I have no USB connections left on my PC to be able to connect this up to show you that it's not working. But I have connected it up to a laptop, and I can assure you it's not working. And as you can see here, it is switching, but it's not controlling. What I'm going to do now is get a multimeter out and just check for a few volts. I'm sure the 5 volts coming out here is okay. I'm sure. But let's just double check together. I'm just going to check to see if I got my 5 volts going to this USB output to the keyboard and mouse. Black lead to the ground. And I measure this fuse. And what have I got? 4.55. The other side, 4.55. Okay, let's check at these capacitors here. See, do you see it in here? 4.55. Most likely then we're getting the 5 volts to that chip. 0. Let's see what we got here. 0.2. 0. 0.14. I would imagine I would have seen some type of voltage across them two ceramic capacitors. Okay, let's now look and see what we have. Find a data sheet for this. Okay, looking at that, it's an FE1-1S. Okay, so you can find a data sheet on it. I downloaded a data sheet, found one. Let me see what it says. Okay. It has an onboard regulator for 3.3 and 1.8 volt regulator. It's got a clock, 12 megahertz oscillator. Okay. Looking for information that will be relevant to what we want to do now. Voltage and ground. Okay, go down. Here's a block diagram of it. Our 4 ports. I think this chip can do 4 ports by the looks of it. And here is our port going upstream to our keyboard and mouse. Data recovery, an elastic buffer, not 100% sure. Data transmit, phase lock loop. We got our oscillator, and we got our built-in 3.3 volt and 1.8 volt regulators. It would be interesting to see it there. We got overcurrent protection for your USB ports, I would imagine. Power switch control. Okay, that must be the front end where you press your button. Not 100% sure. We got EEPROM, hub activity, LED, port indicators. Okay, right, let's go down. Here's our pinouts. Let's see which pins we need. I see that as VD 3.33 underscore 0. I would imagine that's 3.3 and that's 1.8 up here. I'm not 100% sure, so I'm just going to go down to the description first and see. And here we go. Pin 1 is ground. We got our oscillator on 2 and 3. These are all dealing with down to between pins 4 and 11 to do with your downstream facing port. You got 1.8 volt power output from the 3.3 volt regular inside the chip. So I would imagine on pin 12 we'd have a 1.8 volt. And 13 is it 3.3 for input for 3.3 volt. Okay, right. I'll see what's on that. You got a reset, active low. Okay, plus power. And pin 20 then would be our 5 volts input for the chip, I would imagine. And that goes to feeds a 3.3 volt regulator. So then pin 21, I would imagine it'd be 3.3. Okay, so we have a few pins there we were interested in initially, and we'll go from there. First pin we're going to look at is pin 12. There's 14 pins on each side, so that's 14, 13, 12. What have we got? We got 0. Next one is 13, which should be 1.8, which is 0.2. And pin 21. .2, and then pin 20 is beside it. We have our 5 volts. Okay. I wonder what current that is drawn. I don't know if you can see it on the camera there. It's drawn about 140 milliamps, which is quite a lot for something that's doing nothing apart from powering up an LED. So I'm going to get my thermal camera on and see what's happening. Right, I got my thermal camera connected up to my mobile phone, and let's see here first what we have. Okay. And we got 42 degrees on that. That's glowing. Right, what I have now is I got another working board here, a working unit here. I'll double check that and see what that has. Okay, I'm just going to change over connections. And I'm looking at my amp meter here, and it's not showing any amperage whatsoever on it. Okay, now let's see what we see on the thermal camera. Not sure if I'm seeing anything. It's really getting hot. There's the chip. My finger's reading 32 degrees. That's about 22 degrees. And no amperage. Okay, but I did notice something else on my other one. Let's see. Plug it in. There is something down there getting red hot as well. I could see that glowing from underneath when I was looking at it. Didn't know what it was. but there's something there as well. Let me get that underneath the microscope. It's that device there. I did check for that part number online. I can't find a data sheet on it, so I honestly don't know what it is. But that's getting hot as well. So I'm lucky then that I was given these boards. These boards have other issues with them, so it's not that they're not working. There's other issues with them. They're given to me. So what I can do is I can swap chips over from one to the other and see that get going. Is it this IC that's given trouble? This one here, is it the one that's given trouble and it's drawing too much current from the other board? Well, that'll be easy for us to check because I have another good board here. I'm going to stick it in and see what we get on the thermal camera. Just plug this out. And let's see what we got. Should we line up the pins? Connect it up. And use the thermal camera. I'm drawing about 50 milliamps now. I would imagine that's the short. And this is still not getting hot. A lot of stuff there you've seen is reflections from metal. Don't be worried about that. So I'm going to have to replace this chip first on the faulty board. I did mark them up with an X on it so I don't get mixed up. So that'll be the first place we're going to go. I think we have two faults on this. Maybe someone swapped around boards at an earlier date and now they want me to fix both boards, most likely. Okay, I'll get back to you. I'm going to remove this IC from this board, the one that's showing that it's hot, and I'm going to put one from another board into it. I got both my original boards here now with the X's on them, and I'm going to try that now. I've replaced the little small IC down here. Took a little bit of work. And let's see how it works with this. Don't know if it's going to work or not. Might be other problems with this button board that I'm not aware of. But anyway, let's see. Okay, detected it. Okay. All right, let's see. Does it detect the mouse going in? Okay. Well, I can tell you it does detect the mouse. Let's go to This is using the customer's mouse. Don't know if you're getting it or not. Just see. Yeah. Okay, right. So anyway, two problems with that. I don't know why there's two items blown on it. Maybe there was they just gave me two faulty boards, put them in one to get the other ones going. I don't know. But anyway, that's the two of them working now, and everything's okay. Thanks for watching.